Good day, I am Alfred C. Dulus and today I will be discussing binomial distributions. For our objectives, we have how to determine whether a probability experiment is a binomial experiment, how to find binomial probabilities using binomial probability formula, how to construct and graph a binomial distribution, how to find binomial probabilities using the technology, formulas, and a binomial probability table, how to find the mean, variance, and standard deviation of a binomial probability distribution.
Binomial experiment. First condition. The experiment is repeated for a fixed number of trials where each trial is independent of other trials. Second condition. There are only two possible outcomes of interest for each trial. First, success. Second, or a failure. Third condition. The probability of success denoted by P of S is the same for each trial. Fourth condition. The random variable x counts the number of successful trials. Notation for binomial experiments. First, letter N. The number of times a trial is repeated. Second, letter P. The probability of success in a single trial. Third, Q. The probability of failure in a single trial such that Q is equals to 1 minus P. And X. The random variable represents a count of the number of successes in n trials such that X equals the list of 0, 1, 2, 3, until n.
We have here a sample problem and the instruction is decide whether each experiment is a binomial experiment. If it is, specify the values of n, p, and q and list the possible values of the random variable x. If it is not, then explain why. Our first sample problem. A certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. So we have here our solution. It is a binomial experiment. So the conditions are, number 1, each surgery represents a trial. There are 8 surgeries and each one is independent of the others. 2, there are only 2 possible outcomes, a success or a failure. Number 3, the probability of success is 0.85 for each surgery. And number 4, the random variable counts the number of successful surgeries. We have n equals 8, p equals 0.85, q is equals to 1 minus p, that is equals to 1 minus 0.85 equals 0.15. In x, we have 0, 1, 2, 3, 4, 5, 6, 7, and 8. And for our next sample problem, a jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. The random variable represents the number of red marbles. So our solution, it is not a binomial experiment. So our reason, the probability of selecting a red marble in the first trial is 5 over 20. Because the marble is not replaced, the probability of success for subsequent trials is no longer 5 over 20. So, we have the trials are not independent and the probability of a success is not the same for each trial.
Binomial probability formula. The probability of x is equals to combination of n given x multiplied by p raised to x times q raised to n minus x equals to n factorial over the quantity of n minus x factorial times x factorial multiplied by p raised to x times q raised to n minus x.
Our sample problem. Rotator cuff surgery has a 90% chance of success. The surgery is performed of 3 patients. Find the probability of the surgery being successful on exactly 2 patients. So our solution, we are given that n equals 3, p is equals to 9 over 10, q is equals to 1 over 10, and x is equals to 2. Using the binomial probability formula, we have p of 2 is equals to 3 factorial over the quantity of 3 minus 2 factorial times 2 factorial multiplied by the quantity of 9 over 10 squared multiplied by 1 over 10 raised to 1. So that is equals to 0.243.
Binomial probability distribution. This is done by listing the possible values of x with the corresponding probability of each.
Our next sample problem. In a survey, U.S. adults were asked to identify which social media platforms they use. 6 adults who participated in the survey are randomly selected and asked whether they use the social media platform Facebook. Construct a binomial distribution for the number of adults who respond yes. Which social media platforms do you use? The results are Facebook 68%, LinkedIn 25%, Instagram 28%, Twitter 21%, and Pinterest 26%. So our solution, we are given that n is equals to 6, p is equals to 0.68, q is equals to 0.32, and x are 0, 1, 2, 3, 4, 5, and 6. Using the binomial probability formula, we have p of 0 is approximately 0.001. We have p of 0 approximately 0.014, p of 0 approximately 0.073, p of 0 approximately 0.206. P of 0 approximately 0.328, P of 0 0.279, and P of 0 approximately 0.099. Notice that all the probabilities are between 0 and 1, and the sum of the probabilities is 1. Our next sample problem. A survey found that 17% of U.S. adults say that Google News is a major source of news for them. You randomly select 4 adults and ask them whether Google News is a major source of news for them. Find the probability that 1. Exactly 2 of them respond yes. 2. At least 2 of them respond yes. And 3. Fewer than 2 of them respond yes. So our solution, given n is equals to 4, p is equals to 0.17, q is equals to 0.83, and x is equals to 2. To answer number 1, the probability that exactly 2 adults will respond yes is p of 2 is equals to combination 4 of 2, 0.17 raised to 2 multiplied by 0.83 raised to 2. So that is equals to 0.119. To answer number 2, to find the probability that at least 2 adults will respond yes, we have probability of x greater than or equal to 2 is equals to probability of 2 plus probability of 3 plus probability of 4, that is approximately equal to 0.137. For number 3, to find the probability that fewer than 2 adults will respond yes. We have probability of x less than 2 is equal to probability of 0 plus probability of 1, and that is approximately equal to 0.863. Our next sample problem. About 10% of workers ages 16 years and older in the United States commute to their jobs by carpooling. You randomly select 8 workers. What is the probability that exactly 4 of them carpool to work? So we have here our solution. Given n is equals to 8, p is equals to 0.1, and x is equals to 4. Using the table, the probability is 0.005. So here is our table. Another sample problem. 62% of cancer survivors are ages 65 years or older. You randomly select 6 cancer survivors and ask them whether they are 65 years of age or older. Construct a probability distribution for the random variable, then graph the distribution. So our solution, we are given n is equals to 6, p is equals to 0.62, and q is equals to 38. So we have here our table. When x is equals to 0, our p of x is 0.003. When x is equals to 1, our p of x is equals to 0.029. When x is equals to 2, our p of x is 0.120. When x is equals to 3, our p of x is 0.262. When x is equals to 4, our p of x is 0.320. When x is equals to 5, our p of x is 0.209. And if our x is equals to 6, p of x is equals to 0.057. Okay, so we have here our histogram, and based on our histogram, it would be unusual for none or only one of the survivors to be aged 65 years or older because both probabilities are less than 0.05.
3 important formulas. Mean, denoted by mu, is equals to np. Number 2, variance, denoted by sigma squared, is equals to npq. And number 3, standard deviation, denoted by sigma, is equals to the square root of npq.
Another problem. In Pittsburgh, Pennsylvania, about 65% of the days in a year are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Interpret the results and determine any unusual values. Okay, so our solution, we are given that n is equals to 30, p is equals to 0.56, and q is equals to 44. For our mean, mu is equals to np, and that is equals to 16.8. Our variance is sigma squared is equals to npq, and that is approximately equal to 7.4. Our standard deviation, or sigma, that is equals to square root of npq, or approximately equal to 2.7. On average, there are 16.8 cloudy days during the month of June. Note that values more than 2 standard deviations from the mean are considered unusual. Hence, a June with 11 cloudy days or less would be unusual, and a June with 23 cloudy days or more would also be unusual. That's the end of my video presentation. Thank you for watching.